last series of slides that I'd like to show you are infected with the Plasmodium species, either vivax or falciparum. And I'll first start with Plasmodium vivax. Before you start this slide, you need to remember the fact that there are cells in the blood other than those of the parasites, and this is illustrated fairly well here, where we probably have a small monocyte present, given the fact that it has this little indentation in the nucleus, and then the red blood cells. In and amongst the red blood cells you should see various developmental stages, and in the case of vivax you may be able to find, or you should be able to find, the various developmental stages, everything from the signet ring trophozoite stage to the schizont stages, and you may even find some gametocyte developmental stages. With the video system, it's difficult to get an effective enough resolution to show you very well the developmental stages other than the ring stages. At the end of the pointer, for example, is what would appear to be a schizont stage when I look through the objective lenses. However, at this point in the video system, it's very difficult to determine that. One thing you want to look for is the presence of multiple nuclei. That is the definitive characteristic of the schizont stage. You've got to be a little bit careful in doing that, however, because as you look through the blood smear, what you'll notice is that there are numerous individual red blood cells that are infected with multiple parasites, multiple signet ring, and those could also be multiple schizonts in some cases. And so use that characteristic very carefully. You'll obviously need at least oil immersion lenses before you can even start to make those distinctions. When you look through when you look at the Plasmodium falciparum blood smear, what you'll notice is that there are no schizont stages, and if you remember, those particular stages develop in blood vessels that are closer to the center of the body, the very large vessels, and so you don't see schizonts in peripheral blood. And so that's the only criteria that I'm going to ask that you use for making those distinctions. In the slide labeled Plasmodium falciparum gametocytes, the thin blood smear, you should be able to find the banana-shaped gametocytes present in the red blood cells. And I'm not going to require that you tell the difference between a male and a female, or the macro and the micro gametocytes. If you can just simply recognize those as the gametocyte. You can actually see the gametocytes more effectively in the thick blood smear of the Plasmodium falciparum specimen, and what you'll notice in that particular preparation is that there are no red blood cells, and typically the way they do this is expose the blood smear to distilled water that will lyse all the red cells and most of the white cells. The gametocytes, of course, won't be harmed, and if you think about it for a second, these gametocytes have to be built to withstand the conditions of the mosquito stomach, and so conditions that would otherwise harm the red cells don't have any effect on these gametocytes. and the people that diagnose malaria infections take advantage of that, because if you remember from lecture, the appearance of these gametocytes is often used as a means of differentiating one species from another. This is a section taken from a mouse that has been infected with malaria and then allowed to the infection is allowed to progress for a fairly long period of time. And this was a paraffin section taken from that. You should notice the presence of the hepatocytes, similar to what we saw previously in the Hymeria slide. But in addition to that, you should notice that it almost appears that there's dirt or some other kind of material also present in that slide. And what that black material actually is the hemoglobin that was left over from the lysed red cells. And we talked about this in lecture, how the fact that how the liver functions to clean up a lot of those infected cells, and that the hemoglobin from the red cells tend to accumulate in the liver, causing a condition known as black liver. And not only is the liver black at the macroscopic level, but also at the microscopic level, all the black fragments you'll notice.